Thanks a lot. So yeah, this year's hackathon, we decided this year to host a hackathon on Panoptes. And so if we could jump to the next slide, please. Clicker list here. So what is Panoptes? I figure we should talk about that first. Panoptes is an open source end-to-end monitoring system that we built at Yahoo and brought over into Verizon Media as we got acquired. And what the problem was that we were trying to solve was we were over polling. We had a lot of different monitoring systems. We wanted to consolidate the polling and consolidate the monitoring systems and build a distribution bus. Thank you. Build a distribution bus to then send those metrics anywhere that they needed to be. And so that's what we built with Panoptes. What makes it special? We've scaled it to Verizon Media scale, so we're monitoring tens of thousands of devices on it in production right now. It's battle tested. We've been running it in production for 3 or 4 years. It's extendable and has a plugin architecture, and a lot of what the hackathon was built around extending those plugins, building those plugins, coming up with new and interesting integrations to do with Panoptes. And finally, it's open source, so anybody can use it. So brief history, we actually started working on Panoptes in January of 2016, and it's kind of been a journey with NANOG because a lot of our major announcements have been at this conference. So in 2017, we announced Panoptes at NANOG. We came and talked about it and talked about what it was we were working on. 2018, we open sourced the platform. 2019, we actually made the open source a lot more accessible by wrapping it in a Docker image so that people could quickly install it and get up and running with it. January 22nd of this year, we pulled the trigger and decided, let's do a hackathon. And in 2 weeks, the team pulled it together, and we hosted the hackathon this past Sunday. And so why did we do this? Well, we are very interested in getting community engagement with Panoptes. It's kind of been a one-company show so far, but we would love to have contributions come in, and we'd love to see people get involved with the platform and really start to iterate on it and make it better. Looking for new ideas, new ways that we can stretch the platform, and finally we wanted to help out and make NANOG awesome. So with that, I'm going to hand off to Derek to talk a little about leading up to the hackathon.
Hey guys, so what went into this? A whole lot. So once I told the team we were doing this and the shock wore off, they quickly jumped into assessing and addressing all the issues that we had with the Docker image to get that up and running, to build a document test and build a repeatable setup process, as we knew it was crucial to get the teams up and running as soon as possible so that they can work on the hacks. Which one? Next.
The green one.
It isn't. There we go. Also, we were able to leverage Tsudo's amazing cloud emulation platform, which made things a whole lot easier for us to spin up an infrastructure and a topology that we could poll against. So we built a multi-vendor for diversity and a simple full mesh topology with nodes running iPerf to generate metrics and with synthetic traffic. And so this was just an interesting slide we want to share. Okay. Sorry. Back. Know this. All right. Sorry about that. So we want to share this slide about what the teams kind of focus on. So primarily the plugins that the teams kind of honed in on were the polling plugin, distribution plugin, and also the time series. The time series database. And so, not sure, probably time constraints, with the other plugins that we had, but this was interesting observation that most of the teams kind of focus on these plugins during the hackathon. And just a huge thank you to the Panoptes team for getting this done in short notice. I know it was a lot of work, and so a testament to how awesome you guys are. Tsudo for allowing us to use their platform, and NANOG and the committees, Hackathon, for making this all possible, walking us through our first hackathon. And I don't have it here, but lastly, just all the participants, because truly it's your time and effort that makes this event amazing. So thank you for doing this hackathon and future hackathons. So with that, I think I'll pass it to Ian to announce the winners.
Thanks. Yeah, and just to underscore, we had 8 teams this year, 42 participants in the hackathon, so great turnout, lots of engagement. And the winners are,
Like the Oscars.
the Panoptes Graph team and the Purdue team, who did a Prometheus integration. So I think first on the stage, we'll call up the Panoptes Graph team.
All right, well, hello everyone. I'm Zoe Blevins. I'm joined up here by Flavio Castro, Arnott Jain, Joshua Sahala, and Chris Woodfield, and Pramila Singh also participated in this hack with us. So our goal was to take metrics out of Panoptes, enrich them with topology data, and forward them to a graph database. And I'm going to walk you guys through how we did that. So first step was to write a polling plugin in APOM. The Panoptes team was kind enough to supply us with a starter plugin. So what we did is we took that starter plugin, we used the get interface counters method in APOM to pull our interface metrics. We did some Panoptes built-in transforms to create a conversion from the counters to the input and output rates. And then the get LLDP neighbors method was used to enrich that data with LLDP data. So we created this generic plugin, and then we had each of our per vendor plugins inherit from that. We chose Napalm because it did have support for most of the devices we chose, and there's a little bit of a caveat there that we'll talk about when we get to challenges. But that's the direction we took with the polling plugin. And so this is an example of a metric that was produced that was read off the Kafka bus. So you can see that we do get the input and output rate in both a counter and a gauge. The gauge is that converted rate. And then the dimensions we added were our neighbor port, our neighbor name, the speed of that link so that way we could calculate utilization, as well as the interface name that's the source of the metric. So the next step was to create a bridge to our graph database. So we chose Neo4j. It's got pretty good community acceptance. Full disclosure, none of us had touched it before. So this is the model I came up with when using library called NeoModel to produce an ORM on top of Neo4j. This model is likely not perfect. I'm sure those of you with graph database experience probably have some feedback on it. But in general, we created our router object, and then we describe this relationship that we store our utilization metrics as well as port details on. So this was the graph visualization we wanted to get out of that. We'll talk about in challenges, but for a little bit we were worried we weren't going to get real metrics in here, so I went ahead and hard-coded the graph using our graph database just to get what we were hoping for. You can see that same full mesh that was shown on the Panoptes slides earlier. And so this is what we got. We got really, really close. Unfortunately, Cumulus doesn't have a Napalm driver, and the Nexus Napalm driver doesn't support get interface counters for some reason. So we weren't able to get metrics from those two nodes, but because we were able to get the rest of the graph, the only link we're missing is the link between Nexus and Cumulus. One other thing to point out is if you look at the bottom there, that's the data that we actually got about that link. So that's what we're storing in that relationship and what we could use to then calculate utilization and potentially color this graph. So I'm going to hand it off real quick to Flavio to talk about our challenges.
Thank you. So, hi everyone. So just to talk a little bit about the challenges, I want to preface a little bit that if people haven't, even ever touched Napalm, it's a great starting point if you want to, get started with automating things. It's supposed to be a multi-vendor open source project. So the first challenge that we had was that there was no Napalm driver for Cumulus, and that's something that if someone has it or has interest, that would be nice to see there. That was the first challenge. The second challenge was that, for example, for Nexus, as Zoe mentioned, we did have the napalm driver, but for some reason, the counters weren't being reported properly. So that was the second challenge mostly that we had. And a third reason, and that was due to a hardware failure for the iOS XR device that we had. We did have everything. We did get values back from the counters, but then we had some issue that the hardware was misreporting the values themselves. But other than that, we were able at the end to get data from EOS and Juno successfully, so that was nice. And yeah, that's it. So
one more challenge we hit, and sorry, Varun, to call you out here, but relative imports aren't supported in Panoptes. So we wasted a good hour and a half to 2 hours trying to get our plugins to load, and they were silently failing, and we didn't know why, and we were all kind of poking at it. And turns out relative imports aren't supported, and it doesn't really log when you do that. So if anybody wants to contribute back to the Panoptes project and fix that bug, it'd be pretty great. And then, as Flavio mentioned, we did have the iOS XR counters being misreported. So what would be the next steps for this hack? Obviously, we would need to implement some napalm methods if we chose to continue using napalm as the polling base. Another option would be to move these LLDP dimensions into the enrichment plugins in Panoptes. We chose not to do this because we would have to do it SNMP based for the way that it's architected. And LLDP data via SNMP is wildly inconsistent across vendors, at least when I last looked like 5 years ago. That may have changed now. Another thing we really wanted to add, and what we were hoping to have done in this hack, was to actually show the thickness or the color of those links based on the percentage of utilization on that link. That would have been a really cool visualization. And then finally, graphs are great, topology maps are pretty, but there's a lot more you could do with the graph database. So it'd be really interesting to, now that we've got this data fed into a graph database, come up with some cool uses of that data. So I want to give a shout out to the Verizon Media folks for putting this hack together in a really short time, and then also to Sudo for supplying the lab, and specifically Tom Beecher and Yuahi for getting those devices configured for us during the lab to support LLDP and get us SSH access. So thanks a lot, everyone. And if you want to see the source code for what we did, we've got it up on Git. Thank you.
All right, good morning, everyone. My name is Nigel Wilson. I'm from Purdue University, and I'm joined on the stage with my colleagues Jacob Slater, who's also from Purdue, and our friend Basil Fillin from Mythic Beasts. And as Ian and Derek explained, a lot of the project with Panoptes was working on that plugin side, whether it be discovery, enrichment, or polling plugins, adding some functionality, adding new ones, kind of changing things around. But we kind of wanted to take a different approach to it. We wanted to look towards that back end where all that data was being stored in the databases. Specifically, we wanted to look at the time series database with InfluxDB. And that's where we thought, well, how can we make this better? Considering Panoptes is open source, we wanted to look at some more open source options. And while InfluxDB has open source options, that high availability is behind a paywall. So what's the solution to that? Prometheus could be the option. Unlike InfluxDB, Prometheus allows that high availability at the open source level. Additionally, there are plenty of companies that are using Prometheus over Influx as is. So why not add that accessibility to multiple companies and vendors using Prometheus as well as Influx? And this took a little bit of a challenge because, as we can see from this slide, they're not necessarily the exact same structures. InfluxDB uses a push-based system where Prometheus uses a pull. as well as how they're querying these data types is different because Influx is using SQL, while Prometheus is using a more simplified query model. Neither of these are better or worse than the other, it just changes how we have to go about manipulating that data to get it to that database. And now I'll actually pass it off to Basil to add some visualizations and explanation as to how we did that.
So Prometheus primarily uses a pull-based system in order to ingest data. This wasn't directly compatible with the push-based system that existed in Panoptes when we started. We modified the Influx to be a Kafka consumer in order to ingest data for Prometheus. We used Redis as an intermediate database to buffer data before it was pulled by the Panoptes exporter into Prometheus. We directly translated Panoptes dimensions into Prometheus labels to make sure we had metadata for the data that we were ingesting. This is Jacob for the results.
So when we first started this, we were provided with a Docker container that had an instance of Grafana set up with some example graphs feeding in from InfluxDB. And after letting it run for a little bit, we ended up with something like this. We then, after letting it run for some time with the Prometheus exporter, attempted to duplicate the graphs just to demonstrate that we had in fact captured the data that we thought we had. After around a few hours of letting it run, we ended up with a result that looked something like this from the Prometheus side, which looked relatively similar. We then attempted to duplicate this for other graphs, and again, managed to reach what we felt was a relatively similar result. These are not for network interfaces on, say, a switch. The example data that was provided and the data we chose to use was from just the Linux host machine that the Docker instance was running on. However, the same the same imports that were used for the Linux machine because of Panoptes can be used across any other networking device. Thank you for your time.
And we would just like to take the time to thank NANOG for their NCI initiative that allowed Purdue to actually come here and work on the hackathon and participate with NANOG, as well as thanking the Verizon Media team and to Sudo for putting on the hackathon. Thank you.